this video, I'm going to go over some algebra topics that show up in calculus classes, and some students struggle with them. I will try to do all this in under 15 minutes, but if I can't, I will make another video. So please read through these 10 topics that I'm planning to go over by doing some problems that usually show up in calculus problems. So let's go and talk about the first one. The first example is an order of operation problem, and you learned that you learned the mnemonic PEMDAS, which everybody knows about it, but people still struggle with applying it. So P parentheses, E exponents, AM multiplication, D division, A addition, and S subtraction. But the fact that M is before D does not mean that we do multiplication before division. M and D, multiplication and division, are the same category, and so we will do them in the order they come. If I have a division before multiplication, I'm going to do the division. AS, the same thing. If I have a subtraction before the addition, we'll do the subtraction. So the problem that I have here, we have subtraction, division, multiplication. So obviously, multiplication and division are before the subtraction. So we are not going to do the subtraction first. We are going to do the division. So we copy everything. 2 minus 2 divided by 2, it's 1 times 2. Now we ended up with a subtraction and a multiplication. We'll do the multiplication. So we'd copy everything. So 2 minus 2 equals 0. Order of operation, even if applies, and it has to be followed because it shows up in problems that even contain letters. So let's take a look at the factoring. I chose here 5 problems, and the most common one that shows up in almost every class when I teach calculus is x squared minus 9, or in general x squared minus y squared. So this is a difference of 2 squares, and we're going to do x minus 3 times x plus 3. Feel free to multiply them back and see how you obtain the same thing. So a squared minus b squared, it's a minus b times a plus b. It's a formula that it's very, very important. It shows up many times. X squared plus 6x plus 9. It's another type of problem that shows up. Now, if we take a look at the numbers, this 9 is 3 squared, and this 6 is 2 times 3 times x. So when we have a perfect square, and then we have a perfect square, and then 2 times the product of those numbers that were giving us perfect square, this is actually x plus 3 squared. So it is a perfect square trinomial. A squared plus 2ab plus b squared is equal to a plus b squared. Now let's take a look at the next problem. We notice that we have a common factor. Each of these terms can be factored by a 2. So we get x squared minus 10x plus 25. And so we notice yet again that we have x squared, it's a perfect square. We have 5 squared, a perfect square, and then we have 2 times x times 5. So we get 2 times, and now again a perfect square trinomial, x minus 5 squared. So the difference between the b and c is that here we have minus and here we had plus. So the only change I can make here, if it's minus 2ab, then it would be a minus b squared. Now another interesting problem is x squared plus 1, which many people write it's x plus 1 times x minus 1, but it's not. This is prime. We cannot have any real numbers that we can multiply together to get x squared plus 1. So the same with x squared plus 4, x squared plus 8, plus 16, whatever. If it's plus in between, it's prime. If it's minus, it is difference of squares. Now, when we have this type of problems, where this is not a perfect square, this is not a perfect square, so any of these two formulas that we wrote here does not apply. Then what do we do? Well, we try to factor it using this rule. We are looking for two numbers that have the sum -1. This -1 was actually the coefficient of x, so whatever it is, that would be for sum. And the product is actually the product of 2 times -3. That's -6. So we try to figure out some pairs that have the product. We look at the product first. So 2 and -3, and if we actually add them together, they give us -1. So we started on the right foot. We found exactly the numbers that we need. What do we do with them? Well, we take these two numbers and we replace this middle term using those two numbers. So we have 2x squared plus 2x minus 3x minus 3. So mathematically it's correct because these two are actually -x. Now we ended up with 4 terms, so we are going to group them. The first two have a common factor of 2x, so we end up with x plus 1. The last two have a factor of -3, so we get x plus 1. So x plus 1 is a common factor, so I'm going to factor it out, and we get x plus 1 times 2x minus 3, and this is 2x squared minus x minus 3 in factored form. Now let's take a look at the third type of topics that show up in calculus classes. Solve the quadratic equation. So one way to do it is to factor it, like we did before, but the way that works all the time is to actually use quadratic formula, which is x12 is -b plus minus square root of b squared minus 4ac, everything over 2a, where a is the number in front of x squared, b is the number in front of x, and c is the constant. So in our case, a is -3, b is +5, and c is 2. So we are going to get -5 plus minus square root of 25 minus 4 times -3 times 2, everything over 2 times -3. So let's compute this. So I computed this using the order of operation and everything, and I ended up with two solutions, -1/3 and 2, and this would have been hard to... Actually, I think you could have factored it. Yes, you could have factored this problem as well, but it's good to practice quadratic equation. Okay. Now, let's look at another topic that shows up many times. Complete the square. So basically, what do we need? Sometimes we need to have a quantity squared plus something else. So I need something squared. And we saw in the previous one when we had to factor that sometimes if I have these quantities, perfect square, and 2 times x times 3, then I can complete this. I can get the quantity squared, but not all the time it works, right? If we take a look, this is x squared. Good, it's a perfect square. This is a perfect square. Unfortunately, in the middle, it's -2 times 4 times x. In order for us to complete the square, to get x minus 3 to the second, I needed -2 times 3 times x. So because we don't have that, this is how we complete the square. We rewrite the first two terms. I don't write the third one just now. And I'm going to add with some term which we obtain by half 8 squared. So basically, half 8 it's 4. 4 squared is 16. So if I add 16, this trinomial is going to become a perfect square. But let's not forget, it was 9. So mathematically, the equation has to be the same, right? So I'm going to subtract the 7, and that makes it 9 again. Now these three are actually x squared, 4 squared, and in the middle I have negative 2 times 4 times x. So it's x minus 4 squared minus 7. And we completed the square. We have the perfect square quantity that we wanted minus something. Sometimes it's plus and sometimes. But this rule, make sure you take half of the number that is multiplied by x. Let's talk a little bit about exponents and radicals. Well, majority of you know that a to the n times a to the m is a to n plus m, and a to the n over a to the m is a to n minus m. So this is not an issue. But sometimes we have negative exponents. Sometimes we have rational exponents. So when we have negative exponents, we can transform them into positive this way. X to negative 3, it's 1 over x to the third. When x to negative 4 is at the denominator, this becomes 1 over x to negative 4 becomes x to the fourth. In part C, x to 4 over 3 can be written as cube root of x to the fourth, where the denominator of 3 becomes the index of the radical, and this exponent 4 becomes the exponent of the x. Now this one can be also simplified in cube root of x to the third times x. Why? Because cube root of x to the third is just x, and then we are left with cube root of x. So it was written in the simplest form. Now when we have x to negative 12 over 5, this can be written 1 over x to 12 over 5, which is 1 over 5th root of x to the 12. And we can actually simplify that by doing 1 over 5th root of x to the 10 times x to the second. So we get 1 over x to the second, 5th root of x to the second. Let me write that again. 1 over 5th root of x to the 10 times 5th root of x to the second. So 1 over 5th root of x to the 10, it's actually x to 10 over 5, which is 2, times 5th root of x to the second. So this would be written as a radical. And it works, backwards works the same. If we have in radical form and we want to write it in fraction form, then we will have n root of x to the m, it's x to m over n. Now, something that I want you to keep in mind about radicals, if you have an even root, like 4, 6, 2, 4, 6, 8, and so on, so square root, fourth root, you always have to have a positive number under the root to get real numbers, and you're always going to produce a positive number. Now, if you have odd numbers like third root, fifth root, seventh root, you can have positive and negative numbers or negative numbers under the root, and you're going to produce positive and negative numbers outside.